In the world of programming, C++ stands as a titan, a language of power that has shaped and is shaping the digital realm. C++, with its rich history and continuous evolution, has stood the test of time, proving to be a versatile and efficient language that programmers can trust. It has been around for more than 3 decades, yet its relevance and significance have not waned. From the very essence of your computer's operating system to the video games you enjoy, C++ plays a role. It's a preferred language for creating system and application software, embedded firmware, and much more. The reason for its widespread use? It offers a powerful blend of high-level and low-level programming capabilities, giving developers a unique level of control over the hardware. This ability of C++ to work close to the system hardware while still providing high-level programming features makes it a potent tool in the hands of skilled programmers. From operating systems to video games, from desktop apps to databases, C++ has its footprint everywhere. In the world of C++, everything revolves around variables and data types. Let's break this down a bit. Imagine you're creating a video game. Your characters need names, health points, strength levels, right? These are all examples of data, and in programming, we need a way to store this data. That's where variables come in. Variables are like containers for our data. They hold the information we need for our program to function. Now, these containers need to be suitable for the type of data they're holding, and that's where data types come into play. In C++, we have a variety of data types to choose from. When we're dealing with whole numbers, for example, we use integers. But what if we need to represent a number with a decimal point? That's when we use floating point numbers. And when we need to represent a single character like A or Z, we use the character data type. Now, how do we create these variables? Well, first, we declare them. This is like telling the program, hey, I need a container for this type of data. For instance, if you want to declare an integer variable named score, you'd write int score. Simple, right? Next comes initialization. This is where we assign a value to our variable. So if we want score to start at 0, we'd write score = 0. And just like that, we have a variable named score holding the value 0. But what good is a variable if we can't use it? That's where input and output operations come in. We can use the cin command to take input from the user and store it in our variable. And when we want to display the value of our variable, we use the cout command. So there you have it. Variables are the containers that hold our data, and data types determine what kind of data these containers can hold. Mastering variables and data types is your first step into the vast world of C++ programming. Control flow in a C++ program is like the brain in a body, directing actions, making decisions, and keeping things in order. In the realm of C++, control flow is the mechanism that guides the execution of your program. It's the traffic conductor at the bustling intersection of your code, ensuring that everything moves smoothly and efficiently. Let's start with conditional statements, the decision makers of your program. They are the ones asking the questions and making choices based on the answers. The simplest form is the if statement. It poses a question, and if the answer is yes, it executes a block of code. Then we have the else if statement. It's like a second opinion. If the first if statement's condition isn't met, else if steps up, poses its own condition, and runs its code if the condition is true. Finally, we have the switch statement, the multi-option decision maker. Instead of asking a yes or no question, switch looks at a variable or expression and matches it to a list of cases. When it finds a match, it executes the associated block of code. Now, let's move on to looping constructs. These are the repetition masters of your program. The for loop is the most structured of the bunch. It's excellent for when you know exactly how many times you want to repeat an action. The while loop, on the other hand, is a bit more flexible. It keeps repeating an action as long as its condition remains true. Then we have the do-while loop. It's similar to the while loop, but with a twist. It guarantees that the action will be performed at least once, even if the condition is false from the get-go. These conditional statements and looping constructs are the brain of your C++ program, controlling how it thinks and operates. By understanding and utilizing them effectively, you can create dynamic, responsive, and efficient programs. Understanding control flow allows you to dictate how your program thinks and reacts. Functions in C++ are like the building blocks, allowing us to construct efficient, organized, and modular code. Imagine functions as miniature programs, each designed to perform a specific task. When you need to perform that task in your code, you simply call the function. This not only saves time but also makes the code easier to read and maintain. Now, how do we create these helpful building blocks? Well, it's a three-step process: declaration, definition, and calling. Declaration is like introducing your function to the program. It's a statement that tells the program the function's name, what type of data it returns, and what inputs it needs, if any. It's like saying, hey, there's a function called add. It takes 2 integers and returns an integer. Definition is where the real work happens. This is where you specify what the function actually does. For our add function, the definition would include the instructions for adding the 2 input numbers and returning the result. But a function is of no use if it just sits there, right? That's where calling comes in. When you call a function, you're telling the program to go and execute the set of instructions defined in that function. If the function requires inputs, you provide those values when you call it. Now, let's talk about function parameters, return values, and scope. Parameters are the inputs to the function. Return values are what the function gives back after performing its task. Scope, on the other hand, refers to where in your program the function and its variables are accessible. In a nutshell, functions are a fundamental building block of C++ programming. They help us write clean, organized, and reusable code. With functions, you can break down complex problems into manageable pieces, making your journey in C++ programming smoother and more enjoyable.